is that when we go forward into like forces or move into momentum or electric or magnetic fields, is that they all work the same, they're all vectors. Just the letters we use are going to change, but the processes are always going to be the same. So I wanted to tell you the steps to solve the problem first, just in a general context, and then we'll look at a displacement scenario where it kind of ties everything together. Now that being said, this method that I'm going to show you, right, it doesn't always start at step 1 and end at step 7. It could be reversed, it could jump in halfway in between, or maybe you don't need to do the whole thing. It depends on the question. So this is a tool, right? My job is to give you tools, like a general way to do things, and then you have to understand the process, and then you can hone your skills. The second thing I want to emphasize before I start is, where did I put my headset? All right, so the next thing is I'm aware that when you have two vectors and the question only involves two vectors, that this method is not the best way to do it. It's kind of tedious. And and you know this from calculus class, you can use the sine law and cosine law to get the same answers that we're going to get in this longer process. The advantage of my process is twofold. One, it works 100% for more than two vectors, which we'll see a lot of this year. And two, it ties into, when you get into calculus, you start using something called matrices or matrix. And there's a much faster way to solve it once you learn the math skills for it. And it all uses components. You guys, have you done vectors yet in math? With IJK?
It's not in calculus and vectors. We did see in grade 12.
There you go. Okay. So you do this later on. So what I'm going to show you will be a little bit different than you do in vector, like in your math classes, but they all work kind of the same. I just do it from a physics point of view. So your general method is, number 1, is to break all your vectors into components. So step 1 is always draw a diagram. Just have to move Olivia back here. Okay, so step 1, draw your diagram. So in your diagram, you need to have your compass and label all components. So you have to label all the vector components and have a compass. You know which one's north or which are your positive directions. Okay? So there's no numbers in a diagram, right? Number 2 is your table of values. So I call a TOB. And in here we have the numbers or / output trig ratios. So you can have the numbers or the trig ratios for the vector components. So if the x component uses sine, you would have the vector sine the angle. Right? And this will probably make more sense when we actually do our question in a second. So if you have one vector, let's call it A, in your table of values, it's going to have two additions to your table of values because you're going to have an AX, so how far it goes horizontally, and an AY, which is how far it goes vertically. So each vector has two parts to it. Its horizontal part and its vertical part. Okay? Step 3 is work in each dimension independently. So your X, or I refer to it as X, or the horizontal component, but they're not always the same. So the X component is independent of the Y component. So whatever happens sideways does not influence what happens vertically. So that's why we use components. So we break it into horizontal and vertical. Whatever happens in one dimension does not affect the other dimension. Because they're vectors, that means they have directions. So whatever happens going north doesn't affect what the motion is going east. Okay, so they're separate. Which is new to you because we're used to everything kind of going together. 4. So sometimes the answer stops here, and you'll see that happen. Sometimes we have to go on to step 4, which is to find the resultant vector. So sometimes, like in our question in a second, we're going to have to find the overall displacement, right? So we have to find the overall vector. To find the overall vector, you have to do 2 math processes. Number 1, I'm going to go up to the top here. So 4a is use the Pythagorean. So use the Pythagorean theorem for the magnitude of your final vector, right? So you, in step 3, you're finding the x and like resultant displacement, right? You're finding the resultant displacement in the x, the resultant displacement in the y, and in 4, you're putting things back together. So you have a new right angle triangle. So use the Pythagorean theorem to figure it out. I don't know if I spelled Pythagorean right. You guys, you may not know this, but I'm terrible at spelling. B. Use the tangent ratio to find the direction. So you're always going to use the tangent ratio to find the direction of the resultant vector. You never use sine, you never use cosine, because you want to use the values that you found in step 3 to get the direction. Just in case some fluke you forgot to take the square root when you did the Pythagorean theorem, then your direction wouldn't be right then. So you're losing more marks, so it just decreases your chances of losing marks. Maddie.
So with 2D motion, do you always make it into a triangle?
Everything's about triangles. Yeah. Every vector has its own triangle, and then we add all the small triangles to make a big triangle, and then we find the hypotenuse of the big triangle. Does that make sense? Weird, but that's the way it works. Patty?
What did you say decreases the chance of errors?
You're making sure that you always, so when you use a tangent ratio, which I call 4b here, right? If you use sine, you'll probably still get the right answer. But say if you forgot to take the square root of the Pythagorean theorem, right? And then you use sine in part b, right? Your hypotenuse is wrong. So that way your angle would be wrong too.
So I think it's better to use like tan.
If you use tan, then at least if these numbers are right, your direction will still be correct.
Yeah. Okay.
Does that make sense?
Yeah.
Yeah. Any questions with that process? It's very generic. Like obviously we don't have any context for this yet. We will in a second. But that's kind of the same process every time. You'll see too that in part 4, I usually draw a diagram. I redraw the resultant vector. with its X and Y components, just so I can visualize where my angle is and which direction it's going. Because that helps me, but maybe it doesn't help you. I don't know. Any questions with that? I know from your perspective it probably doesn't make sense. So if we do an example, I'm hoping it kind of solidifies things. But I put like a sticky note on this note, so when we come back to this again and again and again and again, that you kind of know the process. We just, as I said, we just change the variables as we go from our different topics. So here we go. I have 3 questions. Actually, we'll do the first one together. It only has 2 vectors in it.